So with our jam-packed agenda today, we'll be bringing speakers from all over the world to talk to you. We have our first speaker that we're going to be bringing on in just a few minutes. Malika is an engineering leader for large-scale distributed systems and AI architectures. I'm really excited to have her joining us and talking to us. So I am going to bring Malika on stage. All right. Well, welcome everyone, and kick us off, Malika.
Awesome. Thank you both. I am super excited to be here and talking with you all and hopefully continuing the conversations after this as well. Thank you so much for putting together such a great agenda. Good morning, everyone. I'm Malika. I started my career building distributed systems, thinking deeply about scale, reliability, and performance. Over time, I moved into platform engineering, building the abstractions and infrastructure that help teams move faster. And more recently, I've been working on AI driven systems in production, where models are part of the core product experience. And what I have found is that many of the assumptions that work really well for distributed systems and platforms start to break when you introduce AI. So, what I want to share today is that shift. What changes when systems go from being deterministic to learning systems, and what that means for how we build our platforms specifically. We have fundamentally changed what software is. Traditional systems are deterministic, same input, same output. AI systems are probabilistic, outputs vary, quality shifts, and behavior evolves. So we're no longer just serving APIs, we're actually shaping behavior through our systems. And that breaks many assumptions our platforms were built on traditionally. Our platforms were designed for reliability and correctness, but AI introduces variability and ambiguity. And the most dangerous part, failure can be silent. Latency looks good, error rates look good, but user experience is getting worse. That's a completely different failure mode than what most systems are built to detect. If you look at teams doing this well, there's a clear pattern. Evaluation is not a step, right? It's a system. Feedback isn't just dashboards, it's built into the product experience. Models are not directly called, they're abstracted behind gateways, and this, I think, is a very critical one. And experimentation is constant because you're optimizing behavior, not just correctness. This is less about tools and more about how the platform is structured. If you look at large scale recommendation systems as an example, the kind that serve millions of users, there's a very clear pattern here. Every user interaction becomes feedback. Clicks, watch time, skips, dwell time. That feedback flows back into the system continuously. They're constantly running A/B experiments, not occasionally, but as a default mode of operation. Models are never directly integrated into the product code. They sit behind the platform abstraction so they can be swapped, tuned, and iterated on. And most importantly, ranking quality is driven by evaluation systems that combine both offline metrics and real user behavior. This is what an AI native system looks like in practice. It's not static, it's constantly learning and adapting. AI native doesn't mean adding a model somewhere in your stack, right? It means AI is in the critical path of decisions. And more importantly, it operates as a loop. For this, let's take an example. A user takes an action like searching or interacting with a recommendation. The model makes a decision what to rank, what to generate, what to suggest. That interaction produces feedback, clicks, skips, engagement, and that feedback flows back into the system to improve the model. And this loop runs continuously. That's how top companies building AI native systems, not as static deployments, but as systems that learn from real usage over time. Think about evaluation systems and that feedback loop. If your platform doesn't support this loop end to end, your system will eventually degrade. Even if it looks fine on the surface, your dashboards are green, your first level metrics can be green all over, something will not connect with how the users will be engaging with the product. Without this loop, you don't have an AI system, you probably just have a snapshot, and that's something to be mindful of. We had a system that looked completely healthy in production. This was another example where latency was fine, error rates were fine, and user experience started degrading very slowly and quietly. And when we debugged and went a little deeper into what might have been the root cause for that, earlier in the iterations, we didn't really have an evaluation system that was wired into the platform. We weren't running shadow tests or new variants. We couldn't tie behavior back to specific model changes. So we shipped something that was technically correct, but behaviorally worse. And that's the trap that's really hard to catch. Your existing signals don't catch this. And it's so much about tweaking and calibrating your existing signals so that they can actually catch this kind of drift. If you don't invest in evaluation, nothing else works. You can't compare model versions meaningfully. You can't safely roll out changes. You can't learn from production. So decisions get made by intuition, which doesn't scale. Evaluation, that's why, is not just tooling. It's control plane for the AI systems. If you look at large-scale recommendation systems, evaluation is not just one thing, and it's a stack, right? You cannot introduce evaluation as a small modular system in one of your tech stacks. It is about introducing end-to-end in your pipeline. At the foundation, you have your offline evaluation, curated data sets that let you compare model versions before they ever see users. But that's really not enough. On top of that, you have online experimentation, your A/B tests with guardrails to make sure you don't regress key metrics. Then you have to layer in the real user behavior. It could be clicks, engagement, dwell time as a continuous signal of quality. And for different kinds of products, it's going to be different signals. But catching what are those user behavior signals and embedding them back is a key step in the process. And importantly, these systems are constantly re-ranking and tuning based on that feedback. So evaluation is not just a checkpoint before deployment. It's a continuous system that governs what gets promoted, what gets rolled back, and how the model evolves. And this is something that I see all the time in organizations. If you have your evaluations not checking something, do the right teams and folks have the authority or the influence to actually say we don't do this deployment? We actually roll back and make a decision out of it and not just observe it and flag it somewhere. That's a key difference that I've seen in organizations that actually value evaluation systems. That's why I call this as a control plane, because it's what actually controls the behavior of the system in production. And the architecture itself changes, right? Like you're no longer just calling services and storing data. You're inserting a model and wrapping it with evaluation and then feedback loops. That loop is what becomes the system over time. Your platform needs to make this pattern easy. Otherwise, every team rebuilds it differently and poorly, and you're not able to reuse your patterns. If you look at how large-scale platforms evolved internally, the biggest change wasn't just technology, right? It was how the platform itself was structured, and that goes back to the early architectural designs. Very early in this process, I observed that machine learning lived in silos. Different teams build their own pipelines, models, and tooling until they converge later, and that wouldn't scale. So the shift was toward a more centralized platform, not to control the teams, but to provide a more common foundation. And of course, it is an iterative process and teams arrive at that point. But what they built, what's often called as a paved road, was a very critical point in that process, which typically becomes like a standard path from experimentation to production. And that maturity is what really green signals this system, and really values that feedback loop and evaluation being um, uh, um, yeah, taken seriously across the pipeline. And instead of every team figuring out infra, deployment, and monitoring, the platform handles that, and that's where the efficiency kicks in. On top of that, they introduced shared abstractions like common feature stores and increasingly shared foundation models. So teams weren't building the same intelligence repeatedly, and they could actually use this across their tech stacks. And they also made experimentation and deployment self-serve. So product teams could move fast without waiting on platform teams. This was key for product teams because they wanted to experiment new product surfaces without having to wait for 7 to 8 days, as an example, for retraining. And critically, this platform was deeply integrated with data and infrastructure, not sitting off somewhere to the side. This is also another key shift where integration with data is key. And then what all of this results is not just better models, right? It's a system where learning scales across the entire organization. So, in my observation, before this shift happened, teams would ship models and better models. But after this shift, the company ships actually learning systems, and that's a very significant mindset shift as well. There are a few patterns that consistently work, right? Model gateways to abstract providers and allow flexibility. You can think of versioning, not just for models, but prompts and features, because small changes can significantly shift behavior. Shadow deployment, so you can test safely without impacting users. And I can't emphasize enough about feedback pipelines, really capturing the real interactions as learning signals. And if these aren't built into your platform, teams will continue to duct tape them, and at some point it won't scale. I want to quickly talk about how this shows up in concrete ways, right? Model deployments behave differently. They're not just like stateless services anymore. Scheduling becomes about GPUs and costs, not just about CPU and memory. You need routing across models, not just instances. And pipelines start becoming more and more stateful because evaluation and feedback are now part of the system. So the abstractions we build for microservices do start to fall short at some point of time. If you're a Kubernetes or a platform engineer, this shift is very tangible, right? Before AI native systems, most of what we built was around stateless services. You scaled horizontally, you scheduled based on CPU and memory, and you balanced across identical instances. And your metrics were things like latency, error rates, the golden SLAs and SLOs of the system. That world was very well understood, and Kubernetes is incredibly good at it, as are some of the other abstractions. But AI systems introduce a different set of constraints and boundaries. Now we are dealing with model aware workloads where behavior, not just availability, matters. Scheduling isn't just CPU anymore, it's GPU's cost and even model specific constraints. Instead of routing traffic across identical instances, you're now routing across different models. You're trading off quality, latency, and cost in real time and continuously. And your metrics evolve from system health to behavior quality. Things like relevance, correctness, or user satisfaction proxies. So the shift is not that how we used to think about platform engineering becomes irrelevant. It's that the layer above the platform becomes significantly more important, and that shifts on how we think about AI platform going forward, because that's where decisions about models, behaviors, and evaluations eventually live and are shared out as abstractions to other teams that will be using it. If you're building this today, start with evaluation and feedback, not just infrastructure. Keep your abstraction thin, especially around model access, and optimize for experimentation speed. because that's a key indicator about how this is going in terms of value for the users. What you should avoid, in my opinion, is overbuilding platforms too early and hard coding model calls. And most importantly, treating AI systems like traditional APIs. They behave very differently. Um, uh, so typically what gets lost is everything that actually matters, right? Like there's no versioning tied to behavior, no evaluation to compare the outputs, no control over how that behavior changes over time. If this happens, the system drifts. So outputs change, quality shifts, but you don't have the signals or structure to understand why. And you end up debugging symptoms instead of controlling the system. And I feel like that's the cost of treating AI like APIs. And that's one caution that I would say is best to be avoided. My last slide. And I feel like the reason this shift matters is not just technical, right? It's very structural in how we build teams, organizations, and systems. AI platforms are not just infrastructure layers, they are learning systems, which means the primitives change. You're no longer just thinking about compute storage and networking. You're thinking about evaluation, feedback loops, and experimentation as core building blocks. And the organizational model changes too. Platform teams can't just provide infrastructure and step back. They have to enable that learning across product, ML, and engineering. And ownership shifts. You're not just responsible for uptime anymore, you're responsible for whether the system is actually getting better over time. And that brings me to your role in this. If you're a platform engineer, you're not being replaced in this shift, right? Because I've been through this journey in first person. You're becoming more important because someone has to build the systems that allow models to evolve safely, to be evaluated continuously, and to improve from real world feedback. And that's very critical to how products thrive. So, in my head, the real question is not how do we run AI systems? The question is how do we build systems that can learn, adapt, and get better every day? Because in today's world, the teams that win are not the ones who deploy models the fastest, right? They're the ones who can actually learn the fastest. And can you build your platforms that way? That's it. Thank you. And I'm always available after as well to continue the conversation and take any questions.
Awesome. Thank you. I am going to let me remove.
Yeah, and just as a reminder for everybody, we are only using the chat, so use questions. If you have questions, please put them in the chat. We will ask all of our speakers to hang out a little bit longer so you can continue to ask your questions in the chat, and the speakers can continue to answer them. I didn't see any questions come through, but we forgot to make that announcement before.
Well, and I liked what you said around enable the learning. I think it's really interesting. We've talked in the cloud native space for years around like the cultural shift and the change that needs to happen, and you bring people along. And I think obviously that's what we need to be doing in this space as well. Awesome. Well, thank you so much for being here. Great talk. I did love the family sound effects for a brief period of time. It's always good to have the next generation joining us.